We'll start by creating a customer transaction. A customer has an identifier, which is auto-numbered, a name, an address, a phone number, and an attribute called info, where we will add any comment or information that we want about that customer. More specifically, we will add this information in a rich text editor. Let's save, and now we will add the product transaction. A product has an ID, a description, and a price. Note that as I add the attributes, they are displayed and I can select them from there. A product also has a photo. Let's run it, and Genexus will make an impact analysis of the changes that will have to be done to the database. And here it proposes to reorganize so it will create a product table and a customer table. We can see this if we make a diagram of transactions and tables. We will create a diagram object. We will drag the customer and invoice transactions. And note that Genexus automatically establishes a 1 to n relationship between both entities. The customer ID attribute, which here is a primary key, is set as a foreign key. Now, let's see the tables created from these two transactions. We see that the customer name attribute that is included in the invoice transaction is not included in the invoice table because this attribute was deleted by normalization. When we design transactions, we don't take into account the table structures, but rather the information that the user needs to enter in the application screens. Let's reorganize, and in the meantime, we will make a couple of important considerations. As you may have noted, when I entered the customer and product transactions, I used the same attribute names that I used in the invoice. Genexus considers that the attributes that have the same name correspond to the same concept, and therefore it will realize that the customer ID of the invoice transaction is the same as that of the customer transaction. Based on that, it establishes the relationships of the data model and normalizes the tables in third normal form. Let's add some details on customers and products. Note that the customers are already loaded. This means that when reality changed, we changed the application and Genexus changed the data model without losing any data. This is very important because Genexus guarantees that if an application was working, it will keep working after making structural changes. We will complete this customer's details. In this embedded text editor, we can add any comment that we consider convenient. And highlight information as appropriate using this enriched format. We will confirm this customer and complete some product details. As we've said before, the products are already loaded. So we will add a photo for the mouse. It's interesting to point out that this product was used to generate an invoice. But what happens if I delete it? Genexus won't let me delete it. It generates an error message even though I didn't program any of it, because Genexus also makes referential integrity controls and transactions in a completely automatic way in order to ensure data integrity. Now let's go to the invoice transaction to see the changes that have been made in the invoice with everything that we've done. We will add a new invoice. Note that as soon as I entered the customer code, Genexus retrieved the customer's name. This was done without refreshing the page. Through a combination of web services with JavaScript, it retrieved the data from the server and displayed it on the page without refreshing it. The same happens here with the product's description and price, which now are inferred attributes and are no longer stored in the invoice table. Instead, they are retrieved from the product table. In the next video, we will see a series of tools that significantly increase your development productivity.